Hi guys, to start here on Conic section sheet 24, with a quick read of the question. F is one of the focal points of a double hyperbola. AP is a tangent to the curve, and P is the point of contact. So F is a focal point of one branch of a double hyperbola, and AP is a tangent line. Draw a portion of the curve and locate the directrices and asymptotes. Okay, first thing, back to, I suppose, junior cert really. When you draw an ellipse at junior cert, the tangent lies on the bisector of the focal lines. Same thing here. So the tangent for a double hyperbola lies on the bisector of the focal lines. So the focal lines is the lines that join from point to each focal. So that is the angle already bisected. So the second focal line is here someplace, and the bisector of the angle is the tangent. So we need to double the angle. We're working backwards. I'm going to open my compass to any size sort. Handy way to double an angle is much more accurate than measuring the angle and adding it on again with your protractor. Handy way to double the angle is take the length of the arc out at one side of the angle and swing it out to the other side of the angle. And there's my angle doubled. And that gives me my second focal point. Focal point there, focal point here. Now, the next thing we're going to need to do is we're going to work with the focal distances. So I want to find the vertex and the vertex. I want to find the transverse axis. So another rule of working with the double hyperbola is the difference between the focal distances is the transverse axis. So subtract one focal distance from the other. So I'll take the shorter focal distance right here. And I'll subtract it from the other. The area remaining, I'll just maybe drop it in there with a colour. The area remaining, so the difference between the focal distances, that area remaining is the transverse axis, or the distance between the two vertices. If I open up my compass, I'm going to go quite big now this time so that I stay out of the main drawing. Bisect that line. Well, that's the setting I'm going to use for my compass, half of this yellow line, and I will draw my transverse axis on the auxiliary circle. Before I do, I want to find the center of my drawing, so I'll just go bisecting again. So bisect across this between the focal points. And I'm going to set my compass to half of the yellow line. I'm going to go on to the center point between the focals, and I can go ahead and draw the auxiliary circle. The auxiliary circle then gives me a vertex and a vertex. So now it's starting to look a little bit more familiar. What I can do next is I can actually start drawing the two branches of the curve. So we'll just work with the usual. I might just drop one point in there. I'll actually do this in a colour so that it's a bit more visible. I might just drop one point in between them there, and I'll just step out 10, 20, 30, and that might be enough. So, like we had at the start, focus 1 and vertex 1, focus 2 and vertex 2. have the vertex, and I'll actually label my points as well along there. Number 1, number 2, number 3, and number 4. We have the vertex to a point swung from the focus. And that's not going to give me anything, is it? No. So I have my vertex out to point 2. I'll start out there at point 2, of course. Vertex to a point from the focus. And vertex to the same point from the focus. So that gives me 2 points in the curve. So I wasn't thinking there about my point 1. That's not going to give me anything close to the solution there. I'm going to work out now to number 3. So the vertex to the point from the focus. And while I'm here, I might just do number 4 as well. Vertex to a point from the focus. And so that was vertex to 3 from the focus. Gives me 2 more points. And finally for this half, vertex to 4 from the focus. So that's one half of the curve, and we can just join the dots. You can repeat the whole process for the left side then, so just plotting out our points again. So I think I had a 10 mil, 20 and 30 away from the focus there. I called in points that's point 5, 6 and 7, and I'll repeat the process this time nice and quickly, and I'm going to do them all at the same time now. So all from the one side, so vertex to point from focus. Vertex to point, focus, and same rules, vertex to point and focus. Now that all of those points are now done, again join the dots up. Might be best to add one more point outside, just to one more point might extend that on roughly to the same distance as this one here is. So one extra point there, 5, 6, 7, and extra point number 8 will just bring this on a bit further. Now, what do we ask for next? We're asked for locate the directrices and the asymptotes. So we've part A done, draw a portion of the curve. B, locate the directrices and asymptotes of the curve. Now, what we know this time is, back to one of our rules, that when we're given a tangent, if we join from the point of contact to the focal and go off at 90 degrees, it'll give us a point on the directrix. That's going to be a good start for us. So, join the point of contact to the focus and step off 90 degrees. That will give us this 90 degrees right here. That will give us a point on the directrix. So where that hits the tangent is a point on the directrix. So D1. So from there we can draw an asymptote. The asymptotes are from the center of the auxiliary circle through the intersection of the directrix and the auxiliary circle. So here I can draw my asymptotes. I suppose before I do, I might just make sure I get this really accurate, so I'll take the points from my directrix across. Next point with the directrix across. I'll drop in the next directrix, which will be here and here. So again, D1 for the directrix, and through the centre, through the two directrices, I get my first asymptote, through the directrix, centre and directrix, I get my second asymptote. So that's the question finished. Quite a bit of theory involved in that one, between first of all knowing that the focal lines bisected give us a tangent, so double the angle given to find the second focal point. Then working with your focal distances to find this yellow line here, the transverse axis. The difference between the focal distances equals the transverse axis. Then understanding that the transverse axis sits in the centre of the two focal points, and that the transverse axis gives us the auxiliary circle and gives us the two vertices. Our construction from our points stepped off from the axis, our ordinates, would be next. Knowing that the point of contact in a tangent joined to the focal and stepped off at 90 degrees gives us a point on the directrix was next. And finally, knowing that the directrix intersecting with the auxiliary circle gives us a point on the asymptote was last. So quite a bit of theory involved in that one.